Voyager 1 is officially the farthest human-made object in space. Since its historic launch over 4 decades ago, the spacecraft has been making its way through the depths of the cosmos.
There was something before the Big Bang, and we're going to detect gravity waves from the instant of creation.
Gathering data no one had access to before. But things have just taken a terrifying turn. Physicist Michio Kaku has just announced that there's been a spine-chilling finding. Voyager 1 has sent a new message back to Earth, and it's something no one was prepared for. Join us as we find out what this terrifying message was and how it might just change everything. Michio Kaku is a world-renowned theoretical physicist and futurist who has made significant contributions to our understanding of the universe. While he is widely recognized for his work in physics, Kaku has also established himself as a best-selling author. He writes about the future of science, the human mind, and the complexities of the human condition. But space exploration is something he's particularly passionate about, and he's written several books on the subject. But one of his most popular works is definitely The God Equation, The Quest for a Theory of Everything. In this book, he dives deep into the captivating concept of a theory of everything in physics, an elusive framework that seeks to unify all fundamental forces and accurately describe the behavior of all matter in the universe. At the heart of Kaku's exploration lies the idea that this theory, often referred to as the God Equation, holds the potential to unveil the deepest secrets of the cosmos and offer profound insights into the nature of our reality. Throughout the book, Kaku traces the historical progression of unification theories, from Newton's law of universal gravitation to Einstein's theories of relativity and quantum mechanics. These milestones represent humanity's relentless pursuit of a deeper understanding of the fundamental forces that govern the universe. In the search for a grand unified theory, which aims to unify the electromagnetic strong and weak nuclear forces, Kaku works to explore various theories and approaches. One prominent contender is string theory. At its core, string theory proposes that the fundamental constituents of the universe are not point-like particles, but tiny, one-dimensional vibrating strings. These strings can oscillate at different frequencies, just like the various notes produced by a violin string. Each frequency corresponds to a different particle, such as electrons, quarks, or photons, and the interactions among these particles determine the behavior and properties of matter and forces. It's like the universe is just like one massive instrument, and all the strings have to do their part for everything to function exactly how it's supposed to. One of the intriguing features of string theory is its ability to include both quantum mechanics and general relativity. Quantum mechanics describes the behavior of matter at the smallest scales, while general relativity explains the gravitational interactions on cosmological scales. However, these two theories have been notoriously difficult to put together. String theory attempts to bridge this gap by providing a consistent framework that merges these theories that seem to be on the totally opposite side of things. In string theory, the vibrations of the strings can manifest as different particles with distinct properties. This allows for the possibility of describing the 4 fundamental forces of nature: gravity, electromagnetism, and the strong and weak nuclear forces, within a single mathematical framework. Not just that, but string theory also proposes additional spatial dimensions beyond the familiar 3 dimensions of space and 1 dimension of time. These extra dimensions, curled up and hidden from our everyday perception, play a crucial role in shaping the behavior of strings and the resulting particles. The existence of these extra dimensions offers an explanation for why gravity appears significantly weaker compared to the other forces, as it may be diluted across these additional dimensions. But Michio Kaku isn't a man that just looks at one side of things. He also looks into the profound implications a theory of everything could have. Throughout DS discussions, he talks about the possibility that such a theory might offer insights into the nature of black holes, potentially revealing their mysterious interiors. Something the world of science has been asking questions about for decades now. Plus, there's also the concept of time travel and the existence of parallel universes, which could be explored within the context of a comprehensive theory. But in all of that, he doesn't leave philosophical and existential questions that were raised by the idea of a theory of everything behind either. Kaku examines whether such a theory could shed light on the existence of a divine creator or offer a deeper understanding of the intricate workings of the universe itself. The exploration of these profound questions adds a thought-provoking dimension to the scientific need to search for a unified theory. The God equation not only provides a comprehensive overview of the history of unification theories, but also encourages his readers to think about the profound questions that arise from our search for a theory of everything. Einstein's pursuit of a unified theory was primarily focused on merging gravity, electromagnetism, and the strong and weak nuclear forces into a single equation. He famously sought to uncover the mind of God by deciphering the underlying principles that govern the universe. Einstein's approach was rooted in his belief that the laws of nature should possess a simple and elegant mathematical structure. In contrast, Kaku's concept of the God equation takes inspiration from Einstein's original idea, but extends it to also include the advancements made since Einstein's time. By introducing string theory into the equation, Kaku's definition of the God equation allows for the potential unification of not only the fundamental forces but also a deeper understanding of the universe itself, from the inside and out. One of the best ways to do that is by looking at real data provided by the probes that make their way through outer space. That's where the Voyager 1 comes in. Voyager 1, launched by NASA on September 5, 1977, holds a remarkable place in space exploration history. Alongside its twin spacecraft Voyager 2, Voyager 1 embarked on an extraordinary mission to explore the outer reaches of our solar system and beyond, providing invaluable insights and scientific discoveries along the way. Originally designed to study the giant planets Jupiter and Saturn, Voyager 1 far surpassed its initial objectives. During its encounters with these gas giants, the spacecraft captured breathtaking images and collected a wealth of data that revolutionized our understanding of these distant worlds. Voyager 1 revealed the intricate details of Jupiter's turbulent atmosphere, including the iconic Great Red Spot, as well as the complex ring systems and enigmatic moons of Saturn, such as Titan with its thick atmosphere and intriguing hydrocarbon lakes. Beyond its encounters with Jupiter and Saturn, Voyager 1 continued its journey into the outer solar system, venturing into uncharted territory. It revealed new information about the outer planets Uranus and Neptune, even though it didn't actually have close flybys of these celestial bodies. The spacecraft's instruments, including the magnetometer, plasma wave system, cosmic ray subsystem, and ultraviolet spectrometer, provide valuable data about the magnetic fields, plasma environment, and composition of these distant worlds. Despite its distance of over 14 billion miles from Earth, Voyager 1 continues to maintain a remarkable line of communication with us. This is made possible through the use of a high-gain antenna, a critical component of the spacecraft's communication system. The antenna serves as Voyager 1's primary lifeline, allowing it to transmit scientific data back to Earth and receive commands from mission control. But the antenna can't just work on its own. To power its essential systems and enable communication, Voyager 1 relies on radioisotope thermoelectric generators, also known as RTGs. These power sources convert the heat produced by the natural decay of radioactive isotopes, such as plutonium-238, into electricity. RTGs have proven to be highly reliable and efficient in providing long-lasting power for deep space missions like Voyager. The heat is converted into electrical energy by a thermoelectric converter, which utilizes the temperature difference between the hot radioactive material and the cold environment of space. While the power generated by the RTGs is enough to operate the spacecraft's instruments, systems, and communication equipment, it's important to note that the available power is still limited. The energy demands of Voyager 1's operations have to be carefully managed to ensure that essential functions receive priority. On the other hand, some non-essential systems and instruments have been gradually deactivated over the course of the mission to conserve power. At this point, the critical systems responsible for communication, data gathering, and transmission remain operational. But you see, the transmission rate of Voyager 1's communication is relatively slow compared to modern standards. With a maximum data transmission rate of 160 bits per second, the spacecraft sends information back to Earth at a very relaxed pace. This is because of the vast distances involved on top of the limited power available for transmission. Even then, the continuous flow of scientific data from Voyager 1 provides valuable insights into the regions of space it encounters. All of this isn't really that easy to accomplish, though. To ensure successful communication, Voyager 1's high-gain antenna has to be carefully pointed toward Earth. This alignment requires constant adjustments to compensate for the spacecraft's trajectory and the immense distances traveled. NASA's Deep Space Network, a global system of antennas capable of tracking and communicating with deep space missions, plays a crucial role in maintaining contact with Voyager 1. The antennas receive the faint signals transmitted by the spacecraft and amplify them for processing and analysis by scientists and engineers on Earth. The ongoing communication with Voyager 1 enables a continuous exchange of information between the spacecraft and mission control. Engineers monitor the health and status of the spacecraft, assess its performance, and make necessary adjustments to optimize operations. The scientific data collected by Voyager 1's instruments, including images, measurements, and observations, undergoes thorough analysis, contributing to our understanding of the outer solar system, the interstellar medium, and the boundary of our heliosphere. And well, in that comes the terrifying message from the spacecraft that pretty much shook the world. NASA's engineering team made a surprising discovery regarding the data being transmitted by Voyager 1. An anomaly was identified from the probe's attitude articulation and control system, indicating that the data being received on Earth didn't accurately reflect the actual conditions aboard Voyager 1. There were terrifying, confusing messages being sent, and no one knew what they really meant. According to Kaku, Voyager 1 could have made contact with a mysterious force after its incredible 45-year journey through the depths of space. Describing the message as terrifying, Kaku revealed that Voyager 1 has transmitted data that challenges our current understanding of physics. Even the wildest theories. The nature of this encounter suggests that the spacecraft has encountered something that defies explanation within the confines of our existing scientific knowledge. This revelation has sparked immense speculation and raised the tantalizing possibility of the presence of extraterrestrial life, or even an advanced extraterrestrial civilization. However, Kaku said that we still need to exercise caution and emphasized the need for a methodical approach to interpreting these findings. That the researchers tasked with figuring out what's going on will get to the bottom of everything. But even then, this unprecedented development had the scientific community in a standstill. The prospect of Voyager 1 encountering an unknown force presents a paradigm-shifting moment, potentially revolutionizing our understanding of the cosmos and our place within it. The possibility of extraterrestrial life or an extraterrestrial civilization being responsible for the unknown force adds an extra layer of mystery and excitement, although the implications of such a discovery are vast, as it would challenge fundamental concepts and theories in physics, astrophysics, and the search for extraterrestrial intelligence, or their search for us. Confirmation of such an encounter would have profound implications for our understanding of the universe, the existence of life elsewhere, and the potential for interstellar communication or even actual collaboration with these unique creatures. As scientists scramble to analyze the data transmitted by Voyager 1, numerous questions arise. What precisely did the spacecraft encounter? Could it be an entirely new form of energy or matter? Is it an indication of a previously unrecognized natural phenomenon? Or does it genuinely point toward the existence of intelligent beings beyond Earth? The glitch manifested as garbled information being sent to mission controllers, providing inaccurate data about the health and activities of the spacecraft. Despite the AACS appearing to operate normally, it was clear that something wasn't quite right. If it were, NASA wouldn't be receiving the messages in the first place. So what was going on? The engineers realized that the AACS was likely the source of the problem and that the signal was probably being rerouted to an old computer, one that had already been shut down to conserve power earlier on in the mission at that point. With that, they immediately got to work trying to fix the issue. In a remarkable turn of events, the solution to the glitch was found in decades-old documents. The engineers dove headfirst into the archives, revisiting the technical documentation related to the Voyager 1 mission. With these historical records, they were able to formulate a plan to address the problem. Their low-risk solution involved issuing commands to the AACS, instructing it to resume sending the data to the appropriate computer. In a surprising turn of events, this approach actually proved to be successful, effectively resolving the issue and restoring the correct transmission of data. The engineers were relieved to see that Voyager 1 was once again providing accurate information about its health and operations. However, the root cause of the glitch remains unknown. To uncover the source of the glitch, the team continues their meticulous investigation. They started looking into the intricate workings of Voyager 1's systems, meticulously analyzing the historical records and technical documentation. Every piece of data is scrutinized, and the command sequences are carefully examined for any anomalies that may have triggered the malfunction. The engineers are determined to leave no stone unturned in their search for answers. The complexity of the spacecraft's systems and the vast amount of data accumulated over decades of space exploration pose a significant challenge. It requires an interdisciplinary approach, with experts from various fields collaborating to unravel the mystery itself. They're meticulously cross-referencing the available information, searching for patterns or anomalies that may provide crucial clues to what could have actually caused it. Was it really just a glitch? Or was something or someone else at play here, messing with the humans back on Earth? Let us know what you think in the comments below. If you like this video, please give it a thumbs up, and like always, we'll see you next time.